Can you all hear me? Oh yeah, yeah, that was loud. Thank you so much for coming after lunch as well. I'm really impressed, and I'm impressed by all the people in the front row. Where I work in Norway, everyone sneaks up to the back. The front row is always like completely empty, and today there's 2 seats left on the front row if anybody wants to sit here. No, okay. Okay, well, anyway, welcome to my talk. I'm going to be talking today about how I smartened up a simple webcam by wiring it up to the cloud. And but before I get started, a little bit about who I am. So as you can probably hear, I'm an Englishman. I work at a company called Bouvet in Oslo, Norway. So I've lived in Norway for about 20 years now. And yeah, I'm kind of like, in my spare time, I like hacking. I like playing with new technologies, I like building stuff, you know. And when it comes to technologies, it's mainly, language-wise, it's mainly Java and JavaScript that I'm interested in. And domain-wise, AI, the cloud, and IoT. I'm also a member of JavaBin. I don't know if any of you were at Rustam's talk about Wi-Fi earlier on, but Rustam is a leader of JavaZone, which is a conference organized by JavaBin every year in Oslo with about 3,000 people. If you ever get a chance to go there, you should check it out. But okay, so what am I going to be talking about today? I've tried to split my talk up into 4 sections. So I'm going to start by talking about why I did this and my requirements. This was a hobby project. It's very important to make that clear right now. This is a project I did in my own spare time. Once I've gone through the motivation and requirements, I'm going to talk about how I built the physical camera, the first version of the camera. And then I'm going to talk about how I smartened it up. And finally, we'll discuss what we learned, and I'll evaluate the technologies that I used. You can't quite see it here, but my Twitter handle is here, Mark A. West. I'm going to be putting the slides out on my Twitter feed after the talk. So if you check out Mark A. West and the hashtag RigaDevDays, you'll find the slides afterwards. All right, motivation. Now, I've got a line here saying input from stakeholder. Now, this was a hobby project, but it was still a project. And as a project, it had a defined start and end. It also had a stakeholder, my lovely wife. And I'm going to talk about her in just a minute. But our motivation for running this project was basically there'd been a lot of break-ins in the area I live. And all the houses around us, apart from my house, had been broken into. So we were starting to get a bit nervous, because it was only a matter of time. And we have security in our house. We have all kinds of security stuff set up. But we wanted an early warning system that would kind of give us a heads up if somebody was in our garden that shouldn't be there. Because our garden is very secluded, and it's very easy for somebody to get into the garden, and they can spend a lot of time breaking in because no one can see them once they're in my garden. So we draw up some requirements. Now, I'm a developer. My wife is actually a project manager. So this was her idea. But basically, we just wanted something to monitor the garden and send us a warning, right? So basically, a webcam with a live video stream and some kind of motion detection. On the non-functional side, this is where my wife came in place as soon as possible. She knows me. She knows that if she gives me a finger, I'll take the whole arm. In other words, if she says, yes, use all the time you want to make this project, I'm going to use a lot of time. And I will be working on it all the hours that God sends. I won't talk to my wife, my kids, I'll just be working on the project. So her biggest requirement was get it done now. Her second requirement was don't spend any money on it. And the third requirement, which actually was quite a good one, portable. It should be able or easy to move around. So based with these requirements, I have a very simple functional overview. My camera is monitoring activity in the garden. When it detects movement, it sends me an email with a snapshot from the video stream. Simple. So how did I do it? Or how did I build the hardware? Well, on the hardware side, I've put together a shopping list for anybody who wants to do this project in the future. So the whole thing is built upon a Pi 0W. That's one of these. It's a Linux PC. You've all heard of the Raspberry Pi. Probably a lot of you have heard of a Pi Zero. And the Pi 0W is the newest version with inbuilt Wi-Fi. So it's quite cool. Costs about, I think, €9 on its own. But the problem is all the ports aren't really standard. They have a mini HDMI port, mini USB port, mini camera port, and there's only one USB port as well. So you need some adapters if you're going to set it up using a keyboard and monitor. If you're going to do it headless, you don't need the adapters, but Yeah, if you're going to use a monitor, then you're going to need some extra equipment. You're also going to need a SD card, you're going to need a power adapter, and so on and so forth. So for me, I just picked up a kit with all of this equipment, so I didn't have to shop for it separately. But you might be able to find the parts cheaper if you went on eBay, for example. But that cost me €30. The camera module, which is a Raspberry Pi camera module, is one of these. This is a standard camera module. That sent me back €28. And an adapter, because a Raspberry Pi Zero isn't standard, doesn't have standard size ports, I had to buy a special camera adapter, which cost me €6. And then I needed something to mount it on the window. And that's one of these. And if you want to afterwards, you can come and have a look at these things. This is a zero view. So the Raspberry Pi is mounted on the back with the SD card and everything. And it just sticks on the inside of the window. So you don't have to weatherproof it because it's in your house. It's quite useful. I wrote a blog entry about these zero view mounts, and I think they sold like thousands of them afterwards. It really took off, and I didn't get a penny. So what can you do, hey? But anyway, total cost of ownership, €73. Now, depending on your point of view, that's either cheap or it's too much. Of course, you can replace some of the parts as you wish. If you have a Raspberry Pi lying around, just use that. If you have a USB camera, an old USB camera, you can use that. Completely up to you. That's what it looks like, a close-up of the zero view. And as it's a Pi Zero W, there's no need to have a Wi-Fi dongle connected there. So it's just the power. So the hardware's in place. What about the software? Well, remember what my wife told me? She told me that this had to be in place as quickly as possible. So I decided to use something that was already out there instead of building my own solution. So I used something called Motion. Has anybody heard of Motion? There's a few hands going up. Cool. So Motion is like open source motion detection software. And it's great. It has good performance on the Pi. And it has a built-in web server, so it gives us a streaming video. Not only that, it actually monitors the video stream from activity. And when it detects activity, that triggers an event. And the event then can be wired up to a bash script, which sends me an email with a snapshot from the web camera. And it works out of the box. So you don't need to do any additional programming. So, getting this up and running just took me a couple of hours to download it, install it, and configure it. So I'm going to very quickly show you. I've got two cameras running here. I'm just going to show you what they look like, if I can just get this over to there. Yes, there it is. So it's a pretty boring picture, but this is the actual, the video stream from one of these cameras right now. And you see you have like a unique identifier here. You have a date and timestamp. Up here, you have like a little number which tells you how many pixels are changing from frame to frame. And that's basically it. And what you can also do, you can, from this interface, you can actually do all kinds of stuff. You can set the parameters, switch it on, switch it off. So if you manage to connect it to the web through port forwarding from your home router, then you can actually connect to the controls yourself if you want to. Right. So this is an example of an email that I would get from that version of the camera, the first version of the camera running Motion. Just simple. Your security camera has detected motion, and there'd be a picture of the dodgy person in my garden with a little red box drawn around them. So how does Motion work? Well, I've kind of hinted at it already, because what Motion is doing is it's monitoring all of the frames from your video, and it's comparing each frame to the previous one. So here you see frames 1 and 2 are exactly the same. But frames 2 and 3, there's been a change. There's a thief has come into my garden. And in this case, alert would be triggered, and I would get an email with that picture. So that's how Motion works. And here's some examples of the camera working last summer when I originally set it up. I went on holiday. The first picture is a neighbours in the garden watering the plants. The second picture is a neighbour's boy looking for things to steal. And the third picture is me when I got back from holiday, and I just went into the garden to see if the camera was still working. So it worked. My wife was pretty happy. It monitors activity, sends a warning, live video. I got it up and running. The whole thing I got up and running in a day, basically. To put the bits and pieces together and configure everything, it took me about 7 hours. Low cost, yeah, €73. I think that's low, but I come from Norway. And finally, it's portable. You can move it around. Yes, very, very happy. Until we started getting the false alarms. And the neighbour's cat uses my garden as a toilet. And on certain days when it's eaten a lot of food, it can be visiting our garden quite a lot. I would get an email message every time the cat came to visit us. I would get an email message every time a cloud moved across the sky. I would get an email message every time shadows moved across the garden. I would get an email message every time it rained, and rain hit the window in front of the camera and dripped down in front of the lens. And at one point, I was getting over 250 emails a day. So you can imagine that I stopped paying attention to the camera. Because when you get 250 emails, you just start piping them into your junk folder. You don't really care. It's like the old story of the boy who cried wolf. When you shout alarm so many times, people stop paying attention to you. So the problem is, of course, motion. Motion is a great piece of software, works out of the box, but it only cares about the amount of pixels changing from frame to frame. It doesn't care about why those pixels are changing. It has no intelligence. So I needed to add some kind of smart image analysis to the camera. What I wanted was basically a filter that would say, no, do not send this email, and yes, send this email. So I had to go back to my project requirements and make a little change. I told you this is a proper project run by my wife, so I had to do a change request. And basically, I asked her if I could change this requirement here. So send me a warning when human activity detected. And she said, okay, as long as it doesn't take too much time and as long as it doesn't cost a lot of money. So I started scratching my bald head and trying to think of, okay, how can we fix this? And the first thing I looked at was OpenCV. Now, a lot of people look, yeah, I've got a guy in the front going, yeah, OpenCV rocks. It does, actually. But what I was going to do with OpenCV, I was going to use face detection. And I thought, okay, if the pictures contain a face, then it's a person. If it doesn't, then it's not a person. But what if the person is not looking at the camera? Or what if they've got their head covered? Okay, face detection isn't going to work. So then I thought about TensorFlow. Yeah. Even more, two fists. TensorFlow is great. It's like Google's framework for creating machine learning or artificial intelligence solutions. And the idea I had was to train and use a neural network to find humans in the snapshots. Yes. And I was really excited about this. I thought, right, that's it. I'm going to Google. I'm going to America. If I get this to work. But then my wife said, no, you're not going anywhere. She said, basically, yeah, this is going to take you a lot of time. My wife is smart enough to know that building a neural network is a lot of fun, but doing it from scratch, it's like building a house from scratch. You'll get it, there's lots of instructions, and you'll get it working, you'll get it built eventually, but you're going to make a lot of mistakes along the way. And it's probably going to cost you more money than you originally planned, or more time. So I had kind of like, a little bit of a blank now. I didn't know what I was going to do, and then suddenly, this is last November, I was reading my Twitter feed, and Aaron Gupta, this is before he started working at Amazon, but it's probably, I don't know. But anyway, he tweeted, he was at the reInvent conference, which is Amazon's conference in the US, and he tweeted that there's new machine learning servers being launched, including image recognition. So I had a look at this, and that brought me to Amazon Rekognition. Now, in this talk, I'm going to swap the terms Amazon and AWS. I'm going to use them interchangeably because AWS is Amazon Web Services, so it's Amazon's suite of web or cloud-based services. But I use Amazon Rekognition and AWS Rekognition interchangeably, just so you know. So Rekognition, it's part of the Amazon Web Service suite of cloud-based products, and it offers you image analysis as a service with a range of APIs, including object detection, facial analysis, face recognition. And it's built upon deep neural networks, so it was actually a service which does the same as what I was going to do myself. And it was launched last November, so it's relatively new. There's alternatives to Rekognition out there, so if you want to create your own version of what I've done, you could use any of these. You could use Google Stack, Microsoft Stack. Clarify is another service which provides pretty good image analysis as a service. So knock yourself out. I decided to go with Amazon, but you could use any of these, and I've tested them out, and they're all just as good as each other. So a quick example of Rekognition running. I just need to find a web browser. Here we go. So if if I just open this fella up here. So I'm going to go to Amazon Recognition. That's what I'm looking for. I'll go to the Amazon Recognition console. And this will give me the ability to upload a picture and do a live image analysis. Now, I seem to be running on the world's slowest internet at the moment, but there you go. Right, try demo. Now I'm going to upload my own image, not use theirs, because I think it's more fun. Here we go. So I'm going to upload that picture that I showed you earlier on, the burglar. So on the right-hand side, you can see what Amazon Recognition makes of my picture. It thinks it might be art, possibly modern art. It also thinks this might be a selfie, and I thought, why selfie? And then I realized it's holding a selfie stick. It's, once you realize, it's logical. Now, the most important thing is it has, these confidence scores here say they show that Amazon Recognition isn't too sure what this is, but it has a 50% confidence that this is a person, which is good enough for me. So it means that I can use Amazon Recognition in my solution. Just come out of this. And so how did I use recognition in my solution? Well, originally, if you remember correctly, my camera was pushing, it was just sending me emails, right? So what I decided to do instead was have my camera just push the picture to Amazon's cloud and let Amazon handle everything. So my camera would just fire and forget and not really care about anything else that happened. So what happens is the camera would push the snapshot to Amazon Web Services, which would then analyze the snapshot, and then if the snapshot contained the person, would send me an email. So basically, the camera is just delegating the whole responsibility for the processing to Amazon's cloud. And this is a bit more of a, not detail, but this gives you an idea of what services are used. So what happens here, I'm going to step you through this. The picture's uploaded from my camera. That's step one. That activates a trigger, which is sitting on S3. Now, the picture's been uploaded to S3. S3 is Amazon's storage service, so it's like Dropbox. In fact, I think Dropbox is built upon S3, but don't quote me on that. But yeah, so the picture's uploaded. It activates a trigger, which then calls a workflow. The workflow is implemented as a step function. The step function does two things. It calls recognition, and then if the picture contains a person, it sends me an email using the Amazon Web Service simple email service. And finally, all of these, there's the email. And finally, all of these components, they're like distributed. They're not in the same container. So there needs to be some kind of security between them. So we use Amazon Web Service Identity Access Management to implement role-based security. So these guys can only call the APIs in each other that they need to call. In addition to all those other services, I'm also using Lambda Functions. They have been around for ages, but they're so hot right now as part of the whole serverless thing. Lambda Functions I've used for implementing the actual logic in the upload trigger and some of the steps in my workflow. And Lambda Functions are basically discrete code units. You can write them in Java, C#, Python, or Node.js. And they're serverless, as I mentioned before, so hot right now. A lot of people don't like the serverless nickname. Some people use function as a service. I don't know, really. I mean, serverless for me means that you as a developer write your code, you push it to Amazon's cloud, and then you don't have to worry about provisioning servers, you don't have to worry about uptime, failover, anything like that. The whole server infrastructure is handled by Amazon. That's how I interpret serverless. Of course, they're highly available and give you a pay-as-you-go model. So you pay for what you use. You don't pay for having your code in Amazon's cloud. You pay for when your code runs. And also, Lambdas give you access to the native SDK. So basically, you can use Lambda functions as your glue between your Amazon Web Services. Now, I'm not going to do a demo because we don't really have time to do a demo, but I just wanted to show any of you who were interested in seeing what Lambda functions look like, just an example. So I'm going to go here to the Lambda function console through, again, the world's slowest internet. Ooh. It should play some music while you're waiting for the pages to load or something. But here's the Lambda functions that I've written for this project, and at the moment they're all in Node.js. I'm actually going to implement some of them in Java, I think, because I just want to see how different an experience that is. But anyway, I'm going to show you one of the Lambda functions, the recognition image assessment Lambda function. This does one thing. It's very, very simple. Now, by the way, if you're a JavaScript coder, look away, because this code is going to hurt your eyes. I'm the world's worst JavaScript coder. I admit that. I write JavaScript like a Java programmer. So that's all the code for that particular Lambda function. All it does is it takes a reference to an object that's been uploaded to S3, runs it through recognition, and then outputs the result. That's it, basically. Very, very simple. And what's interesting here is the handler, the wrapper here, defines 3 objects. So it defines an event object. That's used for passing information in and out of your Lambda function. The context object is for getting runtime context. And the callback object is a JavaScript mechanism for signaling success or failure. Now, you may have noticed that I've written the code directly into the browser here. Now, I mean, who does that really in the real world? Not many people. So you can either write your code into the browser, but if you want to, you can upload it. You know, you can like create a zip file. That's useful if you have like dependencies. So like third-party libraries and whatnot, you can just pack them together and upload the zip file. If you create Java Lambda functions, you upload a WAR file, if I remember correctly, a zip or a WAR file. And the other thing you can do here, you can actually do testing, which is useful. So if I configure a test event, this is a pointer to an object that's already in the S3 storage device or storage service. Zoom out so I can run it. So what I'm doing now is I'm calling this particular Lambda function, or at least I thought I did. Let me try that again. There we go. I'm calling this Lambda function with that picture. So what's going to happen is that the output is here. This is the output from the event object. So this is the labels with the confidence scores. And if I scroll down here, you will see everything from the log. So everything can be logged and like everything can be, all the logs, sorry, can be looked up in Amazon's CloudWatch service. So that's basically it. I don't really want to use a lot of time on Lambda functions because they're pretty simple. Now, of course, they're not a silver bullet. Nothing is, but like for this project, they were perfect. All right, step functions. So step functions are basically used for orchestrating and coordinating Lambda functions into workflows or state machines. And they're relatively new as well, launched in December. And they're defined using JSON files. So you write a nice little JSON document with your states and your transitions between the states. And, oh yeah, by the way, with the JSON files, once you've uploaded a JSON file to Amazon's infrastructure, you get like a nice visualization of the workflow, but you can't edit that visualization. Step functions, same benefits as Lambda, highly available, serverless, scalable, pay-as-you-go. And this is what they look like. When you've taken the JSON file and you upload it to Amazon Web Services, this is how the visualization looks. And it's pretty good, but it's not necessarily always easy to work out what's happening in what order. So what happens is like a file is uploaded to S3 and it triggers this workflow. So the first thing that happens is I run that Lambda function you just saw with the object reference. And the next thing I do, I run another Lambda function that evaluates the labels I got back from the first. The third step is not a Lambda function call, it's just a decision point in the step function, whether I'm going to send an email or not. If I send an email, I send it using the Amazon Simple Email service. And finally, I archive. I archive all pictures, whether they're false alerts or real alerts. And of course, you need an error handler. You need some kind of way of handling if there's like some kind of catastrophic failure there. So that's what the Node Mailer error handler does. It sends me an email if things go wrong. So I think it's a good point now to actually both demonstrate the camera and demonstrate step functions. So I need to find my web browser again. There we are. Now the first thing I need to do, I need to switch on my cameras again because my cameras are in pause mode at the moment. So if I start that fella there, start. And this one here as well. Let me see if I've got them both started back. So what I'm doing is I'm starting the motion detection so that it will actually do motion detection when I actually move in front of them. So hopefully now, at least this one, what about this one? I just need to redo him, excuse me, while I just do this. It's always fun with live demos, isn't it? Yeah, that's dark. I'll explain why that is in just a moment. There we go. Now let's resume. So basically, I've got 2 cameras running. Now, one of them is using a standard Raspberry Pi camera. This is the standard Raspberry Pi camera. And you see that it's quite, oh Christ, it's really dark on that screen. Down here it looks all right. Up there it doesn't look so good. But basically, that's a standard camera. And it's not very good in bad light. Whereas you have also the Pi Noir camera. And that works a bit better in low light conditions. You could use this as a night camera, but you'd have to add an infrared light source to it for it to really work at night. And you see that red dot, that's basically is tracking motion right now. So basically what I wanted to do is I wanted to do a demo and show you how this triggers when a person walks in front of it. So I'm going to walk in front of it now, and like you'll see me coming down here hopefully in just a moment, a nice bald Englishman. Here I come. Hello, here I am. So I go away. So what's happening now, what's going to happen now is that the picture has been, or motion's been activated. So a picture's been generated. It's been uploaded to S3. And once it's uploaded to S3, the workflow will get hold of it. The workflow will then process it. And if it finds a person in the picture, it will send me an email. And there's the email. Oh, there you go. There's another one. And this is, oh, that's from the other camera. So this is actually the picture from the camera that was really dark. Or not, oh, wait a sec. No, you can't see that, can you? Let me show you. Sorry, my mistake. Let me get this out of the way so you can actually see what I'm showing you. So what I wanted to show you is that I've actually got some emails in. There you go. That's an email from the camera that, that was really dark. So that's not too bad. For some reason, he thinks I've got glasses on, or goggles, or maybe that's just what his nickname is for me. Adorable. Yes! For the win. There was another one here from the other camera. And this one's saying, female, girl, smile, dimples. Very interesting. But the most important thing is it's able to recognize a person. And what's happening now is the camera's being fired off because it can see the shadow behind me. It's constantly being fired off. So let me just stop that one so it stops firing off. The green camera. Terminate that one. So what I also want to show you, I want to show you what happens when you put like a non-human in front of the camera. But before I do that, I actually want to show you the step function in process. So let me just open up step function. I'll show you how that looks. So step function. So basically what this is, this shows all for the step functions I've defined, it shows all the instances of the step functions that's been run. So you can actually click on one of these and you can zoom, you can go through it and see what input and output has been going backwards and forwards. What I want you to do is I just want to trigger I want to trigger the camera with myself one more time, and I want to show you what the step function looks like. So if I do it with this fella here, I pull out the green light. There we go. Oh, you can't really see much of that. Let's see if I come up now. Oh, there I am. Hello. Right. So again, the picture's been uploaded to S3. It will be processed, and eventually get to the step function. I actually want to show you how the step function processes it. So just wait for it to upload through the world's, again, slowest internet. It's uploading as we speak right now. Here we go, completed upload. There we go. Let me see if that's the one. Maybe that's the one. Yeah. So I'm going to step through this and explain what's happening. So this step function was triggered by the picture being uploaded. So the first thing here, you see the input is actually a reference, the picture, the bucket, the S3 bucket or repository, the picture's in, and the key for the picture, which is basically the file name and the directory. So the first function was to call recognition with the key that I just showed you, and the output was all of these here with people, human, and whatnot and whatnot. The next step was to call the evaluate recognition labels function, which just looks for certain names here, or certain information here. And the output here, you can see that the alert flag was set to true. So the make alert decision then knew to send processing onwards to the send notification, and finally archive the picture. So that's basically how it works. Now, what about if I try and trigger it with something that isn't a person? Just so you know that I'm not just making all this up. There's that picture again. I'm going to use this high-tech equipment, test equipment, I buy for my wife. My wife doesn't. My daughter. My wife doesn't play with dinosaurs. Not that I know of, anyway. So let's see if we can actually see. Oh, look! The new high-tech remake of Godzilla. Arrgh. Okay. So what's happening is that picture's now being uploaded. Just waiting for it to upload. And once that's uploaded, we'll be able to see the step function that's been triggered, and we'll see that, like, it didn't see a person, hopefully. Okay, completed uploading. Let's do a refresh of this fella here. Normally this works a bit quicker, but unfortunately I've got a bit slow internet today, so apologies for that. Okay, so here you see what's happened when the person isn't in the picture. So the same thing as before, recognition called first. The output of recognition was X-ray, indoors, interior design, room, nonsense basically. Evaluate recognition label, set the alert flag to false. And then the make alert decision just said, okay, let's just archive this. This is nonsense. Right. So that's basically how it works. Right, so what did we learn from this experience? Or what did I learn from this experience? Well, first and foremost, I think, pretty much satisfied all of the requirements. By adding, kind of a bit of intelligence to the camera, I reduced the amount of alerts from say 250 a day to maybe 2 or 3 a week. And the alerts are always when there's somebody in my garden. I never get false alarms anymore. Do we? Oh yeah. Well, I do when the neighbours' kids come in. But luckily, there's been no kind of burglaries. That would be even better if I had I could show you. And then we caught him and we sent him to jail. But no, that didn't happen, unfortunately. But yeah, some positives working with Amazon Recognition. It's consistent. This is quite important. When you're uploading pictures, you want to get the same results. You don't want to get different labels back every time you upload the same picture. So it's consistent. And it also gives you good results from partial images. So if I walk past the camera and you don't see my head, you maybe see my arm and my leg, that will also result in the real alarm. So it's good with partial images. And it handles poor quality pictures surprisingly well. This picture here is actually a reflection from my living room window when I was going to bed one night. And it actually said that was a person with a 99.14% confidence score, which I think is pretty cool. And I don't get any false alarms from the camera. So on that side, I think recognition works pretty well. On the downside, it's not perfect. On the downside, it's a black box. So you don't know what you're going to get out of it until you've tested it a few times, right? So you have to keep sending pictures in there to work out what kind of labels it's going to send back. And there's no telling when they might just change things. Suddenly they might go from being a human label to a person label or something like that. So it's a black box. That's one drawback. Another drawback is you can't provide feedback. I don't know if anybody here uses Google Translate. As an Englishman, I use it all the time. And what I like about Google Translate is that you can actually suggest a better translation. So you can teach it over time to be better. But you can't do that with recognition. If it gets it completely wrong, you can't really do anything. Recognition also struggles with noisy pictures, but all image analysis as a service struggles with noisy pictures. Here's a picture of my daughter sitting on a rock in the woods in Oslo. And recognition can't see a person there. Neither could Google or Microsoft's alternatives when I tried them, and that was a couple of months ago. But I guess these things are going to be improving all the time. Most importantly, the results are only as good as the pictures you upload. If you have a poor quality web camera or the pictures are really blurry, then you're not going to get a hit. And that brings me to my next point, how you can actually improve the results that you get from Amazon Recognition. And basically what we have to do here is we have to go back to motion. and how motion works. So when motion detects activity, it creates an event with a start and an end. And in that start and end, you have a timeline. And on that timeline, you have lots of snapshots. Now, motion can actually choose which snapshot it uploads. So it can decide to upload the snapshot with the most pixels changed. Or it can upload the snapshot with the most central activity. Or it can just upload all of them. Now, of course, it's like throwing mud at a wall. The more pictures you upload, the more likely you're going to send up a picture to Recognition that Recognition can actually process and correctly find a person. But of course, if you upload one snapshot, it will cost you less. And you'll have a lower hit rate. But if you want to increase your confidence, you want to increase the quality, then it's going to cost you more. And the thing, Amazon Web Services isn't free, right? So you have to be pragmatic here and try and find some middle way. Motion is luckily very configurable, so you can do a lot of stuff to control exactly how many pictures it uploads each time it detects motion. Benefits of using Amazon Web Services. I just wanted to throw in a few pros and cons of Amazon Web Services. I've never used Amazon Web Services before this project. Okay, I'm not an Amazon Web Service evangelist. I think it's pretty cool, but I wouldn't use it in production, or I wouldn't use it for big, heavy systems like the ones I work with at work. But Amazon Web Services was very easy to get started with. There's a free tier, which means you get a lot of free processing when you get started for the first year. It's an automated infrastructure, good documentation, and it's a large ecosystem. There's lots of different services there that you can play around with. And, of course, serverless is so hot right now. I can't say that enough. I mean, I'm putting the Java Zone 2017 program together right now, and we've got so many suggestions about serverless. It's like last year it was microservices, this year is serverless. On the downside of AWS, I would say the developer tooling is a bit lacking. That's just my personal feeling. I feel that it's a bit, especially in the JavaScript world. I've heard that it's a bit better with Java, but I'm not really a big fan of it. I think the developer tooling isn't mature yet. Step functions, you define them using JSON files, and that's a pain in the ass. I'm sorry, but editing JSON files manually, please. I mean, maybe I'm just lazy, but I feel that a graphical editor would help out. Of course, when using any kind of infrastructure as a service solution, you're risking lock-in. I mean, that's open. And then, of course, there's a cost. I talked about the cost a little bit before. So I've had 2 cameras running in my garden for the whole of March, and the total cost was $1.07 for that month. That was with approximately 7,000 or 8,000 pictures that were processed in that month. So it cost me $1.07. But that, I'm under the free tier at the moment, which means I get a certain amount of stuff free. So I tried to work out how much it would cost if I have the same usage, and I'm paying full price. Then it will cost me around about $8 a month. So again, you've got to think about whether that's cheap or not. A little bonus. This is a bonus slide I have just in case. Anybody here mess around with S3? Anybody using S3? Yeah. Any of you used it for web hosting? Just a couple, yeah. I didn't realize this until I've been playing around with it for a while, that you could actually use it for web hosting. Because I had a need to do something with all the false positives I get, all the false alarms, because they sit up in an archive directory in S3. And they're very difficult to view through the S3 browser. So I wanted to create a report, and I thought, okay, I'll create a report of all of the false alarms so I can just check them every day and see how effective my camera is. And by messing around a little bit, I found that I could do this all in S3. So I have a Lambda function that basically runs every night and generates the report every day. And then that report is hosted in S3 and available through a static web service. A website, sorry, static website. So I thought that was pretty cool. All right, I'm almost at the end now. As I mentioned before, I'm gonna share all of my slides on my Twitter feed afterwards. But if anybody wants to, there's a link to them on SlideShare. I've also written a blog about my experiences creating this camera on the Bouvet blog. And also, I've got the code on GitHub. So then you can just create the solution. I've got the code on GitHub along with the instructions. All you taking pictures, this will all be on my Twitter feed under the Riga Dev Days hashtag in probably less than half an hour. So that's that. And that's all for me. Anybody got any questions? Yes? Do I save all the footage? Well, you mean the pictures? No. That would take too much. The other thing I had to also ask my neighbor, because when you look at out of my living room window, you see my neighbor's house, and you see their toilet, their toilet window. So I went and asked my neighbor. I said to him, "Do you mind if I have this camera here?" And then I had to show him that I didn't record it, because that would just be freaky. But no, we don't save all basically what it's doing is it's just, the only things that are saved are the snapshots generated by motion in the garden. Everything else is thrown away. Yeah, you can turn this up and down, but I just say if it thinks it's a person, that's good enough. The other thing you can also turn up and down is the amount of pixels that you have that need to be changed before it triggers a motion event. So I can say, like, do I want it just to be like 100 pixels or 1,000 pixels? So I can actually control or throttle how many motion events are triggered by my camera by doing that. Any other questions? Yeah, there's a gentleman there. Oh yeah. You're thinking like, yeah, but I mean the thing is, the code that checks for the labels, it checks for a list of labels. So because one of the funny things is like I tried the camera out once, and I walked like this, so it could just see the back of me, and I had a hat on and a jacket and trousers, and it saw the hat, the jacket, and the trousers, but it didn't see a person. So I updated the labels so it looks for those as well. But like it checks all of the labels as today, so there's no danger of there being so many labels that that person falls at the bottom, if you know what I mean. It checks all the labels no matter what. Does that answer your question? Yeah, right. Any other questions? Yes.
Have you tried to recognize other types of objects like cars or something similar?
You could probably use it. I haven't tried it for that. That's a good idea. I mean, I know some people in a company in Oslo. What they've done is they've just used neural networks for recognizing cars, because it's very easy to train. Because the problem with neural networks, I feel, is the training data. You know, because like if you're going to teach a neural network to see a person, then you need to train it to see a person, and a person can be, there's so many different variations. Whereas maybe training a neural network to see a car is easier. I don't know whether I'm right or wrong there, but I would say that like a car has wheels, 4 wheels, and I don't know. But I've not used it for that purpose myself, no.
But in Amazon Web Services, you did not configure it specifically like to recognize for persons.
No. This service is very generalized. You can't teach it to look for certain like categories or anything like that. I think Clarify you can do that with. I think Clarify you can actually train it to look for a specific category, and you can train it to be even better in that specific category by giving it feedback. So I think Clarify is more featured. There's more features in the Clarify service than, say, for example, Amazon Web Services. Yeah. 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 No, that's a good point. I mean, like, no, I don't have a. No, I mean, like, the security on that, I don't use the standard Pi login and password, for example. But like, yeah, I mean, like, obviously, if they brought down the network, if they broke in and walked over and unplugged my router, it wouldn't work. But the thing is, I have other security in the house, so I have like a camera mounted in the living room, which is wired to what do you call it? It's a burglar alarm. So it's wired to a security company. So if somebody actually broke in, the police would already be on the way. This camera was more for just to see if there's any unwanted intruders in the garden, looking in, seeing if there's things to steal and whatnot. Yeah. Yes? Oh, well, when she's in the garden. Yeah, when my wife is in the garden, yeah, I get loads of pictures. I just send them to her. She gets really annoyed. Especially, I was going to use them in the presentation, but she didn't like how she looked. She said no. So, but the lighting is a good thing as well, a good question, because the standard Raspberry Pi camera is okay, you know. But in Norway, we have very long days in the summer and very long nights in the winter. So like for the camera to be really effective in the winter, you need to use the Raspberry Pi Noir camera, which was the one that gave the better image when I showed it on the screen. But to have that actually work, you need to combine it with a light source, an infrared light source. And the cheap ones you get online are spotlights, and that's no good. You need a floodlight, right? If someone's walking across your garden, you need a floodlight. But then the cost, it goes through the roof. So it's not, you know, I mean, that's one of the drawbacks of this camera as it stands right now. Any other questions? No? All right, well, I'm going to be around the rest of the day. You can see my Twitter feed. So if anyone's got any questions, just come and ask me. Other than that, it was a pleasure. Oh, sorry, no, there was some... Sorry.
Does your camera capture any kind of motion like rain, snow, clouds?
It used to. That was part of the problem in the old version of the camera, because the motion software just looks for pixels changing. So if there was rain dribbling down the window in front of the camera, then it was, oh, I got an email. But snow, it's not too bad. Yeah. Yeah, I'd just like to say it's been a pleasure coming to Riga. I've really enjoyed speaking here today. I hope it's been a nice talk for you guys. And yeah, you just come and find me the rest of the day if you have any questions. Other than that, thank you very much.
I also want to remind you to rate the presentation on your app.
5 stars, 5 stars, 5 stars, 5 stars, 5 stars, 5 stars.